Irrespective of how hard you read, you can't score 98 plus in chemistry if you do not know these important points. What I want to do today is to show you from the beginning of the textbook where JAMB used to set questions to the end and show you some hidden secrets that makes some students to score 98 plus why others don't. Even teachers do not normally teach them during preparations. You are the one that we have to read and discover most of these parts yourselves. So welcome back to Primax Privacy YouTube channel. I'm popularly known as Dr. Sodium, a graduate of microbiology and a medical student from the University of Ibadan. If you're yet to subscribe to our channel, the subscribe button is down below in the video. Just click on the subscribe button. It's not going to cost you anything. You are not going to pay a dime for it. It gives you an advantage to be notified anytime we post a video that will be useful to you, and also to help us to promote this video in getting to so many places. So let's get down into the business of the day. We're going to start from the beginning of the textbook to the end. What I just want you to do is pay close attention, pick out your pen and write on all of those parts that I'm about to talk about. Then keep practicing them till the day of your exam. And I promise you, I can promise you over and over again, if you wait to the end of this video, you are absolutely going to score 98 plus in addition to some of your previous preparation. So let's get down into business. So I've selected all of the questions we are going to be dealing with, and let's start with the first page. Now there's a statement here. Most students might not really note this statement, but if you read the part of inorganic chemistry, you will know that this statement is very important. There's a common question they usually ask here, that if you want to separate sulfides ores, what type of ore? You usually use froth flotation when you are separating a carbonate, sulfide, nitrate, and so on. So whenever you hear the word froth flotation, we are using it to separate sulfides ores, and that's hidden in this sentence here. So that's one part you need to note. Let's move to the next one. Now I want you to note something here. These are part of the things you needed to have known normally because it's written there for you. But you know, most times it looks like it's much for students, but there are some of it that your brain can just think of naturally. But imagine they just ask you a question that which of the following is used as mild antiseptic or as germicide, and they wrote tartaric acid, boric acid, citric acid. Students just get confused at some point because they've never seen it before. So note this part, that boric acid is used as germicide. So note that. Then this is a common question, that which one is used to remove rust. You can see that it's written there. You just need to take note of some of these things. So the one used as in lead acid accumulator, that's H2SO4. We have not gotten to the hidden part, but these are part that I still want you to note because I need you to score 98 plus in your exam. Then don't forget that tartaric acid is used in making baking sodas and other things. Just note this part: baking soda, the germicide, the boric acid, tartaric acid, hydrochloric acid, and H2SO4. Then triazonitrate 5 acid is also used in making explosives. It's a common question, you need to take notes. Then on this page, you will see magnesium hydroxide. That's a common question. For the rest are things you can think of while you are reading, but magnesium hydroxide is usually used in making toothpaste. That's a common question. Funniest thing is that most of these questions, you don't usually see them in your past questions. So that's why most students miss out on them. I'm going to show you everything that you just need to take notes as we are moving on. So take your time to watch the video if you want to score high in your chemistry. Now, one common thing I want you to note here is that they usually ask that which of the following is used as an antifreeze. That is calcium chloride. Note that. Then plaster of Paris, that's calcium tetrasulfate 6. Try to know the formula for plaster of Paris. They asked one of my students last year. Know that. Then this one, using dyeing and calico printing. Try to note those three that I've talked about here and revise them time to time. All these are still basic things that you need to know, but there are common parts you need to revise time to time. So know this drying agent, K2SO4, used to dry all gases except ammonia and A2S. And there's one question they used to ask, that Why is it that you cannot use them to dry those other gases? Because they react with it. So it's a common question. They will react with it. That's why you don't use A2SO4 to dry ammonia. So what do you use to dry ammonia, everybody? So you use calcium oxide. Calcium oxide is usually suitable to dry ammonia. So note this page as well. Even you are used to ask this in their post-UTME questions. Another common question is this, that they will ask you that what is the shape of diamond? Diamond is octahedral, and what is the shape of graphite? Graphite is hexagonal. You are going to see most of these questions in your exam. Just follow through the way I'm talking about them and try to practice them. You will see them and you will share testimonies. So this is also a common part that you might have been taught in your secondary school, that how do you destructive distillation of coal and wood. Destructive distillation of coal will give you coke, ammoniacal liquor, coal tar, and coal gas. Now, I want you to note something here. There was a question they asked at the time that the volatile components are collected as coal gas, which usually contain. Now, look at the one. Which one is more here? You will see the hydrogen is the one that is 50%. So they usually ask that which in the coal gas contain largest amounts of what? So that is written in this place. If you have not read it, you might not really know. It is 30% methane, 10% carbon monoxide, and other percentage for other gases. Please note that. Then another question here is that the non-volatile residue, the solid that is always left behind after destructive distillation, the liquid is usually ammoniacal liquor, while the solid is coke. So please note that part as well. Then note these components of wood charcoal, pyroligneous acid, wood tar, and wood gas. So note those parts. The liquid fraction is the pyroligneous acid. Don't forget that part as well. Now, I need you to note something here. There's a common question they used to ask about Gibbs apparatus. Gibbs apparatus is used to produce, let's say you need gas anytime. So they will ask you that what is used to produce intermittent supply of gas. You use Gibbs apparatus. Now, in the diagram, note something. This part is usually containing liquid. This part is usually liquid, while this part is solid. Please note that. They usually ask that too in the exam. You are going to see it as we are moving further, but I just need to briefly show you one or two things as we are moving on. Okay, if you look at this part, they told you that you can dry, we are preparing CO2. Now, they said something that you can dry it by passing it through calcium chloride to remove water vapor. That's a common thing. Everybody knows that to remove water, you need calcium chloride. But they now say something. The dry gas is then collected by downward delivery, as carbon dioxide is heavier than air. Note that most times the relative approximation of air is around 29. But if you calculate CO2 is around 44. And this simply means that CO2 is heavier than air. So if you want to collect CO2, you will have to like air will be at the top, CO2 will be below. That's what we mean by downward delivery. The one that is heavy will be below, while the one that is light will be at the top. Now here is just 29, CO2 is 44, meaning that CO2 is heavier in density. So CO2 will go down, air will be at the top. So when you want to say that, you will say that CO2 is collected by downward delivery, upward displacement of air, meaning that air is displaced up while CO2 is delivered downward. So that's what this part is saying. I'm explaining this part because we're still going to see some things as we're moving forward. There's a confusing questions at a particular part that I'm going to show you as we're moving on. And that's why I need you to first understand this. So we are collecting CO2 by downward delivery. So you see downward delivery, upward displacement of air, meaning that CO2 is collected at the below, while air is at the top. That's what it means. So let's move on. Now, another common question is hidden in this place. Carbon dioxide gives carbonated drinks. We know that the refreshing taste. So when you open your bottle of Coke, what you see that comes out is carbon dioxide. But they also ask this question that the gas is dissolved under what condition? So it is under high pressure. That is another common question in JAMB. Most of these questions I'm telling you, some of them are in the past question, but most of the ones that are hidden, they are not in the past question. And that's why most students don't score 90 plus. But the student that you would notice that most secondary school students are the ones that used to score 98, 100 in chemistry because they read about you back to back. And that's why. So most of these things are not easy from them. But you that want to score 98 plus, please follow through all of these things I'm saying. Just note that this is more like a quick revision for you that you have read, and for those of you that are just learning, for you to keep one or two things in your brain. So yeast and baking powder are used in baking, and they produce CO2, which cause dough to rise. It's a common question. I don't need to spend more energy on that. Now, note something in this place. There was a question in JAMB past question that says that when you want to produce CO, you use an ethane dioic acid, but you use K2SO4. That K2SO4 is used as what? Note, it is written here, is in your past question. It is written that the latter serves as a dehydrating agent. What serves as dehydrating agent? That's the H2SO4. But if you have not read this part, many people missed it. I saw some past questions that missed it too. But it's directly written here. So it is used as what? Dehydrating agent. So during the preparation of carbon monoxide using ethane dioic acid, CO2 is used, H2SO4 is used as the hydrating agent. Now, they asked me this part during my own UTME. These are common things you need to know. We have three types of gases here: producer gas, water gas, and what we call synthesis gas. Note something, they usually ask you, they can draw this diagram. You will see here you are passing in here. Then what comes out is producer gas. Here you are passing in steam. What comes out is water. So they can just draw the diagram and say what is here. It's in your past question. So when you see steam here, that means it is water gas. When you see here, that means it is producer gas. Now note something. When you are getting producer gas, you will react here with oxygen. Here with oxygen will give you producer gas, and producer gas is a mixture of CO and N2. Note that. Then for water gas, you will mix coke with steam. Coke and steam. When you make coke and steam, mix coke and steam, you are going to get CO and hydrogen. Then for synthesis gas, that is not written here. So for synthesis gas, you are going to mix steam and methane. That's one thing you need to know. So when you mix steam and methane, you are going to have carbon monoxide and 3 moles of hydrogen. So this is what we call synthesis gas. It is just like water gas, but the amount of hydrogen you get here is more than the amount you get in this place. So that's the difference. So this is called water gas. This is called synthesis gas. This is called producer gas. Please note that and note that diagram. Now, there's a common question here too. They will tell you that components of natural gas, just like the one I told you for coal gas, they can say that which one is in the maximum amount, or the main components of natural gas is what? You can see it is 80% methane, 10% ethane, 4% propane, and 2% butane. So that is written typically in this place. So get used to that. So there is a common confusion around this application of electrolysis. Now, for the application of electrolysis, there is purification and there is electroplating. Now, I need you to note something. For the purification, just note this. Note pain. Note the word pain. Purification, anode is impure. That's what you should know. So the impure one is anode, while the pure one is cathode. So for purification, the anode compartment is the impure metal. If you don't really understand electrolysis, maybe you can leave it in the comment section. I will teach you the whole of electrolysis so that you understand what I'm saying better. But for this, you can just note, in case they ask you about purification of metal, because there's a mistake around this place. During purification, the impure metal is usually the anode, but during electroplating, the impure metal is usually the cathode. That's the difference. Impure metal is the anode. So when you remember this, the opposite of it is for electroplating. The impure metal is the anode for purification, but the impure metal is the cathode during electroplating. If I teach the topic properly, you will understand why it is the anode and why it is the cathode. But for now, let's move on. We are only picking out important points they can ask you in exams. So note that page. It's page 213 from your Ababio. All this, if you can put all this into play, even if you have not been reading so hard before, Put them into practice and you will see that you will do very well. So let's move on. Another question they used to ask here is that rusts. What is rusts? Hydrated iron 3 oxide. That is rusts. This is the formula. Hydrated iron 3 oxide. So the oxidation state is for the iron. So that is rust. That's the formula for rust. It's a common thing you need to have known if you have been reading. But just to quickly show you that, let's move on. Now, there is a common question here too, that if bond breaking energy is less than bond forming energy, it will be exothermic. Most students make mistakes here too. There's a way I teach this part. If you want me to teach you chemical kinetics, thermochemistry, leave it in the comment section. Any topic you want me to teach you that you are still finding difficult for now, leave it in the comment section. I will teach you before JAMB comes up. So bond breaking, there's a page too, you will see something like lattice energy. So just compare them. If lattice energy is less than hydration energy, which means if bond breaking energy is less than bond forming energy, it is going to be exothermic. If bond breaking energy is greater than bond forming energy, that is lattice energy is greater than hydration energy, then it is going to be endothermic. So note that part. So looking at this part, they used to ask that the solution of a salt, will it be endothermic or exothermic? So if you dissolve ammonium chloride, sodium chloride, ammonium nitrate in water, it is going to be endothermic. But if you dissolve sodium hydroxide, potassium, and these are the examples they give you in options. But if you have not read this part, you might be looking like, oh, how do they expect me to know this? Blah, 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 blah. Well, one thing about it is that if you have read it in the page, you are absolutely going to know what your answer should be. That's why I'm just pointing this out. There are a lot of hidden facts that you are still going to get to know. Let's move on. So when you get to hydrogen and its compound, they can ask you that what process is used to produce hydrogen. That is Bosch process. That's a common question. But I need you to note something here. During the preparation of hydrogen, CO2 is produced alongside. They now ask, how do you remove the CO2? Most people used to feel like, oh, you can use calcium hydroxide, you can use sodium hydroxide, but it is stated here categorically that the carbon dioxide is then removed from the mixture by dissolving it in water under a pressure of 30 atmosphere. That means you need to remove that CO2 under high pressure. Then whatever solvent that is left can now be removed with caustic soda. So you can see that's the statement here. So if you pick calcium hydroxide, which is the normal thing that you know before, you would have missed the question and you would not know. You will feel like you have done the right thing. Then another thing here is that any unreacted CO, they used to ask this too. How do you remove the CO that is remaining during the Bosch process? Bosch process is production of water gas from steam and coke. So now you remove the carbon monoxide using copper 1 ethanoate, ammoniacal solution of copper 1 ethanoate. So note that. So I think I've already talked about this, just to show you again. So this is called the synthesis gas. So when you use methane on steam, then you get synthesis gas. Now, chlorine is used as a bleaching agent, but there's a common question they ask you here, that if you want to use, now note something, they asked this question last year, just last year, this statement here, and I had to show the students after the exam. Now, in the presence of water, chlorine bleaches most dyes and inks, except those containing carbon, such as printer's ink. Yes, they asked this question, that chlorine can bleach most dyes, most inks, except which one? That is printer's ink, the ones that usually contain carbon. So note that part they asked last year. But what I want to show you here is that chlorine usually bleach by reduction. No, sorry, chlorine bleaches by oxidation. What does that mean? The chlorine will first react with water. Then when it reacts with water, it will form this oxochlorate, this compound. Then the compound will break apart to give oxygen. That oxygen will be added to dye. Then when the oxygen is added to dye, the dye that is colored become colorless. So meaning that addition of oxygen to dye is oxidation. So that means that the chlorine has bleached the dye by oxidizing the dye, meaning that the chlorine there is going to be acting as an oxidizing agent, even for the fact that we call it a bleaching agent. But what really happened here is that the chlorine is acting as an oxidizing agent by oxidizing the dye. So it's added oxygen to the dye. So common question they ask is that chlorine bleaches by what? So you will answer it bleaches by oxidation. Opposite of it is for SO2. SO2 bleaches by reduction. Now, I expected you to have read this, but I'm using it as a revision kind of thing for you and for you to practice as well. Now, they always ask this question that when you react chlorine with sodium hydroxide or an alkali, under cold dilute condition, number one, the temperature must be cold. Number two, it must also be a dilute solution. What will you get? You are going to get sodium oxochlorate 1. Note that. But when you do it under hot condition, that means it is hot and it is concentrated, you are going to get sodium trioxochlorate 5. That's what you are going to get. You can see it here, hot concentrated condition, you're going to get sodium trioxochlorate 5. Now, the formula of triazochlorate and the formula of oxochlorate 1, note it. Sometimes they will not write the name, they'll just put the equation. For this one too, this is the equation. So note it, NaClO3. Note that. Then another thing you need to note here is that they usually ask what is the formula for bleaching powder. That is CaO, CO2.H2O, bleaching powder. So note that for chlorine. Now we are getting to the hidden parts now. There's a question that is so common so that they will say that if you want to dry the gas, you have produced HCl. Then when you want to dry the gas, you pass it through conc H2SO4. So they can, if they're asking you now, the gas is just helping you to remove water as well. So it's acting as a dehydrating agent. But they will ask it this way that HCl produced when you react sodium chloride with conc H2SO4, blah, 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 is dried by passing it through what? By passing it through tetraosulfate 6 acid, concentrated form of it. Now, there's another question I want to ask you. I explained something previously. If you are to obtain chlorine, will you obtain it by downward delivery or upward displacement, or downward displacement, upward delivery? Leave your answer in the comment section, but your answer is actually here too. So now, leave it in the comment section. I'll let you know if it's correct, because there's a question they can ask you on that. So let me just move on about that. So now, from what we have in this case now, this is called the fountain experiment. I've explained it before. You use fountain experiment to test for two gases and to check for the solubility of those gases. The gases are ammonium and hydrogen chloride gas. They are very soluble in water, so you test for their solubility using the fountain experiment. Now, if it is HCl, there is blue litmus because it is an acid. So when the water rises up this tube and splashes, there's the acid that is present in that round bottom flask will convert the blue litmus to red litmus. It's a common question in JAMB. But if it had been that it is ammonia that is present in this tube, then this water would have been put red litmus. Then the color you will see here will be blue. So they can ask you that what color is here while telling you what is present. Or they can ask you that this is the color, what do you think is present? So that is called fountain experiment. So what are the questions here? What are the two gases they use in fountain experiments? Ammonia and HCl. Then what is the color you will see in this place? If it is HCl, you will see red, because acid turns blue litmus red. What is the color if it is ammonia? You are going to see blue, because base turn red litmus blue. Well, let me quickly repeat this. They will ask you, when you mix HCl and ammonia, you obtain a white films. That white films is ammonium chloride. So they can now say a gas is mixed with ammonia. And to give a white films, what gas is that? That is HCl. So this was a question that caused confusion in the past question. So they said that you are producing oxygen, but they now say if the gas is required dry, you should pass it through conc H2SO4 or anhydrous calcium chloride. Then collect it over mercury. But many people chose calcium chloride because they felt like you want to dry it, or they chose H2SO4. No, it is collected over mercury. So the past question says that the gas produced is collected over what? You can see it's directly written here. It is collected over mercury. That's an hidden part you need to take note. Even if it is a day to your exam, you need to go through all of these things again, and you will see some of them in your exam. So then another part here is saying that on heating, oxygen is given us off as colorless gas. Now note this, it cannot be collected by displacement of air because its density is nearly the same as that of air. Now I said something about collection of gases at the beginning. I said if the density of that gas is more than density of air, that gas will be collected by what we call downward delivery. And if it is lesser than that of air, it will be collected by upward delivery. If you think about oxygen and air, actually oxygen is greater than that of air. So you should collect oxygen by downward delivery. But it's written here that you don't use that method because their density is closer. So it's very, very near. It's nearly the same. So you don't use that method. So there's a trickful way they ask this question. Try to note that as well. Now, there's a common question you need to note here. Then after this, I'll quickly tell you one or two things. If you see N2O and oxygen, both of them supports combustion. They rekindle a glowing splint. They can ask you that which of the following compounds of nitrogen rekindles a glowing splint. That is N2O. So note that. Then this is the difference between N2O and oxygen. N2O is called laughing gas. And note the word N2O, that's what I want to say. So let me show you something. There is a name for NO, there is a name for N2O, and there is a name for NO2. And there is also a name for NO2 minus. So looking at what we have here, this NO is usually called nitrogen 2 oxide. Don't because you are saying just one nitrogen here, make that mistake. People make that mistakes in exam. So this is called nitrogen 2 oxide. This is called nitrogen 1 oxide. This is called nitrogen 4 oxide. The difference between this and this is that the oxidation state of nitrogen here is going to be 3, but the oxidation state of nitrogen here is going to be 4. So noting what I've said here is just the name. This is called nitrogen 1 oxide, but students look at it and should be 2 is here. Why not nitrogen 2 oxide? That's a common error. So this is nitrogen 1 oxide. If you calculate the oxidation state of nitrogen here, you will see that it will be 1. So this is nitrogen 1 oxide, and this nitrogen 1 oxide is called laughing gas. So don't say nitrogen 2 oxide. So that is that. Then this one is the one that is nitrogen 2 oxide. Then we usually compare nitrogen 1 oxide and oxygen. Both of them rekindle glowing splints, but one of them has a pleasant smell while the other is odorless. So that's one of the things. And we ask you, when you react them with nitrogen 2 oxide, there will be no reaction. So you react this one with NO, there will be no reaction. But when you react this with NO, you are going to get NO2. And NO2 is known as a brown gas. I'm going to still tell you the difference between a brown ring and a brown gas as we are moving on. So this is the brown gas NO2 when you react NO with oxygen. So note that part that I've talked about too. Now for this part, they usually ask it about sulfur. During production of sulfur, remember that sulfur is produced by what we call Frasch process. But now, they used to ask that the one that has a needle shape, that is monoclinic sulfur. The one that is octahedral in shape, that is rhombic sulfur. It's a common question every year. Then the color for rhombic sulfur is bright yellow, and with that of monoclinic is amber. But note something, when you are heating sulfur, it used to have different kind of nature. But one thing I want you to note as a common question is that they will say that sulfur reaches its maximum viscosity. That means the highest form of thickness at what temperature? That is at 200 degrees Celsius. Please note that. You can read about this page, about this part especially. Note all of those temperature, the color changes, the nature of the sulfur as it is changing. Then when you have it known as flowers of sulfur, note all of those things. But for now, just note that one, that it's sulfur has its maximum viscosity at 200 degrees Celsius. Okay, this was the one I told you about, this thing that this will be the Gibbs apparatus. I told you Gibbs apparatus is used to do intermittent supply of gases. I'm helping you to cover the inorganic chemistry in a short time. Sincerely, this is very useful to every one of you. Pass it across to your friends, and don't forget to subscribe to our channel. Just look at the subscribe button below the video, click on it. It won't cost you anything to subscribe to the channel. God bless you. So Gibbs apparatus is used to supply gas when you need the gas. So we call it intermittent supply of gases. But I now need you to note that there are three chambers in Gibbs apparatus. The solid part is the one at the middle, while the two other parts are the liquid portion. They will ask you that they can give you a reaction and tell you that which one should be at the middle. Just look for the one that is solid. That's the one that will be at the middle, while the liquid can be at the other part of it. So let's move on. If you check this part now, it's a common thing. Just know that most times when you want to dry water, you pass it through calcium chloride. Shege, but note something. They say K2SO4 cannot be used to dry hydrogen sulfide because of what? It will oxidize the hydrogen sulfide to sulfur. But these are hidden questions that have direct answers whenever you see them. Then the smell of rotten egg, that is H2S. Just to quickly tell you something like that. So if they want to test you, they might say, there's a gas that has a rotten egg smell. What do you think that gas is? That is H2S, hydrogen sulfide. So I said something about chlorine used as bleaching agents. They can ask you, what are the two gases used as bleaching agents? Chlorine and sulfur dioxide. Then they will now ask you that chlorine bleaches by what? It bleaches by oxidation. Sulfur dioxide bleaches by what? It bleaches by reduction. Look at the difference here. The dye contains oxygen. It is colored, but the oxygen will be removed from the dye. That's why you have H2SO4. So, and another thing you need to know is that water is usually needed for these guys to act as bleaching agents. Don't forget, you remember chlorine reacted with water to form chlorine water. Then the chlorine water gave the oxygen to the dye. Then the dye became colorless. Same thing here. SO2, which is sulfur dioxide, it will first dissolve in water to form A2SO3. Then it will now remove oxygen from the dye, then to form this. Then the dye will become bleached, become colorless. So note that part. Water is mostly needed for chlorine or SO2 to act as a bleaching agent. But now, sulfur bleaches by what now? By reduction, by removing oxygen. That's what we mean. Why chlorine bleaches by oxidation. They might want to now trick you. Chlorine bleaching by oxidation means that chlorine is acting as an oxidizing agent, while the dye is the reducing agent. But for this case now, SO2 will be acting as a reducing agent, while the dye will be acting as an oxidizing agent. If you don't understand oxidation and reduction, leave it in the comment section. I'm going to teach you the nitty-gritty, break it down in a simple manner that you will understand everything before your exam. So look at this question too, that which of the following, so they are comparing N2O and NO. So which of them is rekindles a glowing splint? You see that this one rekindles, this one extinguishes, this one also extinguishes. So it is N2O that rekindles a glowing splint, just like oxygen would do. So for knowing sake, just know that this HNO3 is called aqua fortis. So they can ask you that which one is called aqua fortis. Also know the formula for global salts. All of these things are important too. There is oil of vitro, that is your H2SO4. There is oleum, that is your, if you add SO2 to H2SO4, you have oleum. So get to know some of these names. But let's move on. These ones are not so important for now. Now, I need you to note something here. Please don't get tired. Make sure you follow this thing through to the end. We are almost through. Now, note, they used to ask you for the composition of corresponding nitrates. All these triazonitrates, 5 salts like KNO3, ZnNO32, AgNO3, when you eat them, you notice something. If you eat potassium and sodium nitrates, you will get dioxonitrate 3 and oxygen. That is what we have here, and oxygen. But if you eat calcium, magnesium, zinc, lead, and all of this one, you're going to get oxide of the metal, oxygen, and a brown gas, nitrogen 4 oxide. Please note that part. But when you eat all these these ones that are not that reactive, you will get metal, not the oxide. You will get the metal, you will get oxygen, and the brown gas. So that is a common thing you need to know about the nitrates decomposition. Also check about carbonates decomposition too. Now, I need you to take important note of this part because most students used to make mistakes. They asked last year, and what they did was that they just wrote this equation. I think they wrote like all of this together. Then they wanted this part. They now put X. They now say, what does this part represent? They just put X. This is what we call the brown ring. But if they're asking you about brown ring, there's brown gas, there's brown ring. For brown ring, you usually use brown ring to test for NO3. Let me write it here. NO3 minus. That's the salt, triazonitrate 5 salts. That's what you use brown ring test to test for. But if they now say which gas will give the brown ring, that is the NO, not NO2. There is brown gas. The brown gas, reddish brown gas, is NO2. That's the color. But for the brown ring test, you need NO. Then for the what are you looking for? You are looking for NO3 minus. Note that part. So you can read this page more on it. They can ask you for the reagents, or they will just write the equation and put what X is here and ask you that what does X represent in this case. So this is called brown ring test. Now, this part came out last year. I remember it came out during my exam too, during my time. Now, they said that most people don't note this. It's something you can actually think about if you have done oxidation and reduction very well. But if you don't know oxidation and reduction, leave it in the comment section. I'm going to teach you. So they said the lower oxidation states of the transition metals occur in ionic compounds to form. So they will tell you that when transition metals are in their lower oxidation states, what do they usually act as? They can act as reducing agents, or they can act as basic oxides. The ones you can oxidize, they usually act as reducing agents, and they usually act as basic oxide. There's a reason I'm saying that, but I don't want to lay too much emphasis on it. It's something you can think about. But now, just if you don't really understand, just cram what we are saying, that when transition elements are in their lower oxidation states, they will act as reducing agents, and they also act as basic oxide. But when they are in their higher oxidation states, they usually form covalent compounds, and they will act as oxidizing agents, or act as an acidic oxide. So note this part. Question came out on it last year in JAMB. Just a quick one here. This is pig iron, cast iron, and wrought iron. When you are producing iron in the blast furnace, I don't want to spend much energy on that. Now, the one that is dirty the most, that is not pure, that you get directly from the furnace, that is called pig iron. Pig, like a leather, dirty. So that is the one that is that has the highest form of impurity. That is pig iron. Then followed by cast iron. Then the most pure form, they can ask you that the purest form of iron is wrought iron. Now look at something. To make wrought iron very pure, they usually ask that the carbon and sulfur that are present as impurity, how do you remove them? You remove them by oxidation. So you oxidize them to remove them. That's a common question you need to take note of. So note this part. We usually use it to test for iron 2 and iron 3. All these are parts that they ask in exam that most students don't know. When you hear anything like blood coloration, blood, like something that looks like blood, they are testing for iron 3. And they cannot give you equation. What the JAMB used to do these days is that they will just write all the reactants, then they will put X here. If you see this guy, thiocyanide, then look at this equation, please. They can put it in the option like that the blood red solution that is formed when iron 3 reacts with potassium thiocyanide is what? This is the compound. Is that taken? Now, if it is for iron 2, you usually have some deep blue precipitates and all of those things. Then for iron 3, you can have deep blue precipitate too, but note the difference. Iron 3 here, but iron 2 here. Can you see? Just note these equations for now. Those are the things. So you can pick your Babio, or you borrow, or you just look at the page and read through it and note this part I'm talking about. Know the blood red that is used for iron 3, then note the formula and know the equation. That's all. Then the common questions they used to ask you, they can ask you anything about alloys. All those ones, they are normal. But there was a question they asked last year that most students didn't take note of, is that they will ask you that which element is present in the higher percentage. Look at brass now. Which one is common? 60 to 80% copper. That means copper is one that is present in higher percentage. Bronze, 90% copper. Duralumin, 95% aluminum. Steel, 99.8% iron. So looking at all of these things, take note of them. Which one has the highest percentage of the elements? That's nickel in permalloy is 78%. So aside that, note the uses of those alloys and note the reasons why you are using them. Those are the things you call the advantages of those guys. So we're almost getting to the end of the textbook now. Stay with me. Don't give up. Don't give up. Gel. So now we are in organic chemistry. Aside you knowing how to prepare organic compounds, naming of organic compounds, isomerisms, there are some hidden treasures that are in your organic chemistry part. So this place now, they said, pass the gas evolved through concentrated sodium hydroxide to remove any gaseous impurities. That is during the preparation of ethene. Then you remove all these gaseous impurities such as carbon dioxide and sulfur dioxide. So they can ask you that the gaseous impurity produced alongside during the preparation of ethene by dehydration, and that's dehydration of alkanol is what? That's CO2 and SO2. Then note this part too, to prevent sodium hydroxide from being sucked back into the flask. So they say you need to empty the conical flask. Insert an empty conical flask between them. So note all of those points. So let's move on to the next part. So common question is this one. They will ask you that which one is used as antifreeze in car radiators. That is ethane 1,2-diol. And it is also used in making terylene. So don't forget that part quickly. Now, on this part too, when during the preparation of alkyne, there's an impurity used to produce. That impurity is phosphine. They used to ask that what impurity is produced during the preparation of alkyne when you pass calcium carbide through cold water. Then the impurity is phosphine, pH 3. And how do you remove the impurity? You remove it by using CuSO4. Then the ethyne produced is usually stored under acetone or something, if you still remember that part. So let's move on. So there are common questions here every year, especially the usefulness of this part. They'll say toluene is used in making explosives. Note that they will just say which of the following is used in making explosives. Phenol is used as disinfectant and raw material. Aniline and this one, they are used for making dyes and drugs. Please note this part. It's a common question every year. Then note the difference between rectified spirit and absolute ethanol and how you remove it, because ethanol, which is generally, look at this. So when ethanol that you normally have after you produce it from fermentation, it is called rectified spirit and it is 95%. But when you now purified rectified spirit by removing some other impurities, you pass it by distilling it over quicklime. They used to ask that question, and that will now give us 99.5% ethanol. That's ogogoro, pure ogogoro. So that is called absolute ethanol. Note the difference, please. So one of the things that still hurts me till today is the question I missed during my UTME that I could have actually scored 100 over 100. But now I missed this question and I scored 98. So they asked me that which of the following is a tricarboxylic acid. That means that it contains 3 functional groups of carboxylic acid. But here now, examples of dicarboxylic acid are oxalic acid, malic, and tartaric acid. While example of tricarboxylic acid is citric acid. So, but I chose tartaric acid during that period, and it was really painful when I came out. And they can ask you that examples of aromatic carboxylic acids, they are salicylic acid, then that's another one, benzoic acid and salicylic acid. That's 2-hydroxybenzoic acid. They are examples of aromatic carboxylic acids. So let's look at the final part. So this part of the organic chemistry notes, they say that you can remove acidic impurities during the preparation of ethyl ether, that's ester. So ethyl ethanoate. Now, during the preparation, you remove acidic impurity by using sodium triisocarbonate 4. Then you dry the ethanol using calcium chloride. Then you discard it and you remove every waste or water left. Then you now distill it to remove ethoxyethane. Please note this part. It's a common question. If you have been following since we have started from the beginning of the page of the textbook and we are almost through with everything, I'm showing you some hidden questions that can that are always asked every year, but most students and most teachers do not teach them. They are parts you have to discover yourself through your intensive reading. But not to stress you out, that's why I'm bringing everything out for you. All you just have to do is write all of these things down, practice them, and you realize that you will do well in your chemistry and you will share testimonies. So let's look at the last part. So this last part, I know someone that missed it, although the person is studying medicine and surgery now in the University of Ibadan. Condensation polymerization, you eliminate some small molecules. Those small molecules are water, ammonia, and hydrogen chloride. But in JAMB, they decided not to. They look at this word copolymer, homopolymer. If they are the same, if you are condensing monomers that are of different types, you have copolymer. If you are condensing monomers that are of the same type, then you have homopolymer. These are common questions in this area. So during condensation polymerization, the byproduct that you get is either water, ammonia, and hydrogen or hydrogen chloride. But if you don't see water in your option, pick ammonia. If you don't see ammonia in your option, pick hydrogen chloride. That's the mistake many people made. So there are a lot of questions all over here and there. If you have any question or any topic that is giving you problem, either organic chemistry, inorganic, naming of organic compound, isomerization, just let me know. I'm going to put you through all of these topics, and I'm begging you once again, just click on the subscription button below if you find this video helpful. Then anything you want us to do for you next, leave it in the comment section. I'm going to do it as soon as possible so that it will help you to excel in your exam. Now, click on the subscription button. You are not going to pay anything. It's not going to cost you anything. Just click on it. You are only helping to promote us and also for you to get notification whenever we upload any useful video. So let's end this by looking at the chapter. Now, at the end of it all, you must have seen all of these questions. You must have kept notes of the important parts. Keep them and make sure that you practice them till the day of your exam. And leave a comment section after your exam to tell me if you saw some of these questions or you did not, and leave it in the comment section what video you want me to make next. I feel I should help you in solving most of the past questions. Just tell me what you want me to do for you before your main examination so we can solve all of the past questions together. Now, some of the points I'm giving you in this video, you might not see them in past questions, but they come out in exams because teachers do not note them. The people that solve past questions do not note them, and it becomes a general problem. But only the minds that have read wide and have noticed some of these points would score 98 plus. It is not just about to read, but having the right information. And if you're yet to subscribe to our channel, please, before you leave the page, make sure you subscribe, help us to promote the channel, and you also get notification time to time.